welcome everyone to this month's live workshop. Go ahead and advance the slide. Talking about mobile vitals, really just anything mobile performance monitoring. My name is Schaefer. If this is the first time that you've been to a Sentry Live workshop, welcome. We'd host these about once a month on a variety of topics. You'll get a chance at the end of this workshop today to just get feedback on topics that you're interested in. Maybe we'll host a future workshop on that topic. And for those of you that have been here before, welcome back. I'll jump into the agenda for the day. We'll do some quick introductions, jump into looking at what are most developers doing to monitor their mobile apps and is it good enough? Check out our new auto instrumentation, how to set that up for iOS, Android, and React Native. Then we'll jump into a developer workflow demo from notification all the way down to resolution. And as always, we'll have time for Q&A at the end. Some quick housekeeping. Obviously, this is being recorded and we will be sending the recording out should you want to socialize it or rewatch it again. I'm sure you're used to Zoom by now. If you see a question that's already been asked that you want to also know the answer to, just go ahead and upvote it. We'll take time a couple times today, one time about halfway through the workshop to answer any questions, and then right before we go into the demo, after the demo, sorry, we'll round up the rest of the questions that we didn't get to. And last but not least, 2-question survey at the end. Please let us know what you liked, what you didn't like. It's going to help us improve these workshops going forward. Today's host is Philipp Hofmann. Philipp's a software developer here at Sentry, and he is joined and supported today by Bruno Garcia, also a software developer. Bruno will be in the Q&A, answering questions there, and also answering questions with us midway through and at the end. So that's it from me. I'll pass it over to Philipp to get to the good stuff. And yeah, Philipp, take it away.
Thanks, Shepard. Just need to share my screen. You can see my screen?
Yes.
Okay, yeah, I didn't hear anything. Okay, cool. So let's get started. Today we live in a world where applications are blazingly fast. Maybe you know that when you are a customer of a modern mobile bank and you're just standing at the checkout of a supermarket, you just hold your card and you even receive the push notification before you receive the receipt. Or you can just stand when you're waiting for the bus, you can see what your friends are doing on social network. You can check how your favorite sports team is doing also within a few seconds. And in such a world, slow applications have really trouble because people, our users already take fast applications most often granted. And if your application is slow, it can really frustrate your users. That can lead to bad reviews, and the competition is just a few taps away. What can we as mobile developers do to avoid such a bad customer experience? First of all, we can be very aware while we're developing. We can catch the most obvious performance issues when we're developing our code. The next level is we can write automated performance tests to make sure certain regions of our code are running smoothly and fast. We can also run them in CI to make sure to avoid regressions in the future. Another thing that we can do is we can use fancy profilers like this one here in Xcode to hunt down bottlenecks and fix them to make our application faster. But all of that feels like testing your application in a lab. Even if you have a very good test set up with realistic user data, it could still be that you're missing quite a few performance issues. To really understand what your users are experiencing out there in the wild, where they might have old hardware, bad hardware, out-to-date phones, a bad network reception, you really need to understand what's happening on their devices. Maybe some of you know this discussion as RUM versus synthetic, especially web developers might be familiar with the term. And what does it mean? It's real user monitoring, what I just explained, exploring what's happening on your user's devices versus testing with all the methods I just explained. And both of them kind of make sense, because if I only would monitor what's happening on my user's devices, I would only know that there's a performance problem when I already released the app, after I released the app. So kind of both make sense, but real user monitoring is also very, very important. And here's where Sentry comes into play, Sentry performance monitoring. With Sentry performance monitoring, you get visibility into how fast your app starts. You get visibility in how fast your views are loading, the duration of your HTTP request, number of frozen and slow frames, and more. You get all of that with not much setup in real time. Just a quick reminder, Sentry is not only about performance monitoring, we also have error monitoring, release health, discover, and plenty of integrations that you can use. But today we focus on performance monitoring. One central part of performance monitoring is mobile vitals. We believe that there are 4 metrics every mobile team and every mobile developer should keep an eye on to better understand how their app is performing. And those 4 metrics are cold start, warm start, slow, and frozen frames. So let's start with app start. When a user taps on your app icon, it should start fast. On iOS, Apple recommends your app take at most 400 milliseconds to render the first frame. On Android, the Google Play console warns you when a cold start takes longer than 5 seconds or a warm start takes longer than 2 seconds. Okay, hey, now what is the difference now between a cold and a warm start? A cold start is when the user launches your application for the first time. This is usually directly after they download the application from the App Store or the Google Play Store, or it can also be after the user reboots his phone or after an app update. This is the most trickiest start for the operating system because the app starts for the first time and it didn't have yet the chance to optimize your app start. For Apple developers, you might be usually used to the term app launch, but as we support many different platforms and on most of the platforms, app start is the term we just go here with app start. And now to the warm start. A warm start is when the app launched at least once and it might be still partially in memory. And the operating systems can do some optimizations to speed it up. The exact definitions differ slightly per platform, and you can check our docs to see those differences. But now, how does that look like in Sentry? What do we do with these metrics? We can take here a look at an example transaction. And if you never took a look at that screen, we will go into detail more on that later. But what we see here on the right is that for the app start, we just put one metric that you can see here. The app start took around 70 milliseconds, which is actually pretty good. And on iOS, we also put here spans, which we again will come to later, for different phases of the app start, how long it took. And here again is important to mention that the whole loading of the first screen took around 230 milliseconds, but the app start was way faster because the app store is all about drawing the first frame. That's the important thing. Okay, that was app start, warm and cold. Next is slow and frozen frames. Why do we measure that? Unresponsive UI, animation hitches, or just jankiness really annoy users and can degrade the user experience. And these are 2 measurements that we think make sense to track to know if your users are having this unwanted user experience. A phone or a tablet typically renders with 60 frames per second. This means every frame has around 16.6 milliseconds to be drawn. If a frame is slower than that, it's a slow frame. And if a frame hangs for over than 700 milliseconds, which is pretty long and really noticeable for the user, it's a frozen frame. Let's again take a look at an example here. This is a transaction, and for every transaction, UI transaction that our SDKs capture, we put 3 metrics on the side here. It's frozen, slow, and total frames. This gives you a good indication if this view had some trouble while rendering. For direct native developers, it can be that you don't have any slow and frozen frames and your app is still not running smoothly, because there's another layer on top, which is the JavaScript event loop. And if the JavaScript event loop doesn't run for 100 milliseconds, we mark it as a JavaScript event loop stall. How does it look like in the UI? We just don't track the stalls. We also track the longest stall time and the total stall time. And this transaction is really, really bad because it took around 5 seconds and I was spending around 1.5 seconds in a stall state where nothing was happening. If I would have such a transaction in my app, I should really do something about it. Okay, now we have all those vitals, those metrics. And what do we do with them? We give you nice dashboards. We're also going to take a look at this later at the demo. This dashboard gives you a nice overview about all the things, all the transactions that are captured in your app. And you see the change of the cold start, warm start, the amount of slow and frozen frames. And this gives you a quick glance on how your application is doing. But Mobile Vitals is just one of the many features of performance monitoring. The whole purpose of performance monitoring is to track the performance of the whole application. And an application usually is just not an app that's standalone and has no backend. Usually there are multiple services involved. And if the backend is slow, the user will also notice this when he's interacting with your application. And users don't care what is slow, the app or the backend. It's still both a bad experience. And that's why with performance monitoring from Sentry, you get insight in how your full stack is doing on a performance level. We do that with a standard technology called distributed tracing, which is already pretty well known on the backend side and on the full stack developer side. But for mobile, it's still relatively new. And it's very important to understand this concept, which is actually really, really simple to fully understand the whole Sentry performance feature. At the core of distributed tracing, of course, is a trace. A trace is simply something that affects your user experience. That could be like signing into your application, loading a screen in a checkout flow, or anything that really affects the user experience. If this is too slow, your users might get annoyed. But both mentioned actions don't only involve your app, but also involve backend actions. And that's why every trace can have one or multiple transactions. These transactions mark the actions happening on different services. So here we could have one that actually should check mobile. Now it says mobile. We have one on our mobile application. We have one for the backend and one for the database server. And to get even more insight into each one of those transactions, we have on the next level spans. So every transaction can have one or multiple spans, and these spans themselves have a parent-child relationship, meaning they can have multiple children and grandchildren. And with that, you get a huge tree-like structure that really gives you a lot of insight into how your whole application is doing on a performance level. And it really helps you to spot bottlenecks. Okay, that was now a quick introduction. Just as a short reminder, we were discussing run versus synthetic. I went through Mobile Vitals, and now you kind of got the basic idea around trace, transactions, and spans. And before we go into the demo, I'd like to pause and see if we already have some questions.
Y'all are being shy today. Feel free to ask questions right now. We can address them before we jump into the demo. I'll give you guys 30, 60 seconds to throw a few in there if you've got any. If you don't, that's okay. We can dive right into the demo. But we'll pause just for a few more seconds to give you a chance to ask a question if you've got one. I feel like I need the Jeopardy music playing.
Yeah, we have one now. How can you measure database spans? Is that right? So maybe I can answer this one. So the SDK offers an API that you can use to measure anything you want to create a whole transaction, which is the unit that gets sent to the server, and to create the individual spans that go within this transaction. And so one way you can measure anything is basically before you make the call, you call start span and then end span. But specifically to databases, data access, this quarter, we're adding more auto instrumentation. So we're looking at, different ORMs that you can use for Android and iOS. The goal is for us to automatically create these spans for you. But until we support automatic instrumentation for your preferred library, you can just do it manually. And if for some reason, you want to let us know about a specific library you want to get automatic instrumentation, feel free to reach out through GitHub, create a GitHub issue, and then we can, discuss over there. I hope this answers the question.
They're flowing in now. Taylor's got a question. How does data collection work when the mobile device is offline? Does it store it and then forward it later?
Right. Yeah. So everything the SDK tries to send to Sentry, first it stores to disk, and then it tries to send to Sentry. And if it succeeds, it deletes from disk. Very often when the device is about to crash, we don't have, or we're not able to open a TLS connection to the backend to send the data via an encrypted channel. And the app just gets terminated, right? This happens on iOS, and very often on Java Air Handler on Android as well. So that's why we persist on disk. And in this case, when the app restarts, we send the data to the backend.
Great. Moving along, how are mobile transactions associated with a server transaction?
Right. So we have auto instrumentation for a few libraries, for example, OKHTTP and pretty much an SURL session, if I recall correctly. Philip can correct me.
Yeah.
And basically what we do, we add the transaction, the trace ID into outgoing HTTP requests. And then Sentry has SDKs for all sorts of backend technologies like Node, Python, Go, .NET, Java, Spring and SPNet. And on the server, it continues the trace. It creates its own transactions and spans, and you can see everything in Sentry as a single view.
We will take a look at that in the demo then, how that looks like in Sentry.
Nice.
Regarding tracing, do I understand it correctly that Sentry needs to be used on both the back end and the front end?
You can only use it, of course, only just in your mobile application, but then you don't get the nice benefit of seeing also what happens on the backend. You can also use it just on mobile and backend and not do the extra work, maybe to don't go the extra mile to connecting those each other. Usually it just works out of the box. But to really see, of course, what's happening on whole your full stack, you need to use the Sentry SDK and also on your backend, of course. Yeah.
How are the logs of different platforms segregated, especially for hybrid apps that use all three, like Kotlin, Swift, and React Native?
Maybe I take this. If by logs you mean
the
events, they would end up on the same Sentry. So Sentry has a DSN, which is basically a URL, and that tells which project within Sentry to send the data. So if you have a hybrid SDK like Flutter or React Native, errors through all layers go to the same project. You see everything in there.
And the same, of course, then for transactions will be in the future there as well.
Right. Yeah, transactions, the same thing. Thanks.
Cool. I'll ask one more and then we'll dive back into the demo. And if I didn't get to your question, I'll make sure to get to it at the end. What is the time scale for the average app start times? Is it 7 days? Is it 30 days? Or just all your events over time?
I'm hoping Philip will take this one.
What is the time scale for the average app start times? I think it depends on what you have selected on top. I think you can select if you just want to know around the last 24 hours, 7 days or 90 days. I think I can try to show that to you also in the demo. Cool. I think it should change accordingly. Yeah.
Cool. Great segue then. I will pass it back to Philip and get to the rest of the questions at the end.
Cool. So then let's dive into the demo. I just going to show you how to set up performance tracking in Sentry. We take a look at how auto performance tracking is working and also how this whole full stack tracing is working. So let's just dive into it. You still see my screen, right? Good. Okay. To set it up, we can directly start from the documentation. I just go here with Apple, iOS, but even if you're a React Native developer or a Kotlin loving developer, We use Swift here, not Objective-C, so the code is very similar and the whole concept is pretty similar. It should be almost the same on every platform, so just stay along and that you should still get the idea. What I need to do here is, of course, first, I should make sure that Sentry is set up how it's usually set up, but I guess most of you folks already know that. That's why we directly jump to performance monitoring. I just click here on Setup, and here it explains a bit what performance monitoring is. And all I need to do basically is just configure a sample rate, the traced sample rate. That specifies the percentage of transactions that the SDK sends to Sentry. It's a number between 0 and 1. And if I use 1, this means all transactions will be sent to Sentry, which is very useful for debugging in development. But if you put that value into production, it might be that you really soon run out of quota. And it also means, it also is not really necessary maybe that you get all transactions. So it really depends on a use case, how many customers you have. You should really maybe lower that value down to, I don't know, 20%, maybe just 1%, 5%. But yeah, that's really hard to say as a general what you should use. So let's go back to our sample app. I just have here in my app delegate, I just throw on here the sample rate, set it to 100%, and we would already be good to go to send some transactions. But first, I want to start with showing you how you can manually create a transaction, because previously I was talking about traces, transactions, and spans, and I just want to show you how you can do it manually to better understand the concept. Here we have our iOS Swift test app for our SDK. It's very, very beautiful. Maybe we're even going to submit it to the App Store, and hopefully we're going to win a design award. Now, of course, I'm just joking. It's just a very simple application that doesn't do much. And I just want that when I click on capture transaction, I capture my transaction, which is not there yet. Here I have something that gets messages and renders messages. In real, it doesn't really render messages. Actually, if I would go down to the implementation, there's just a bunch of delays in there to just emulate something. But let's just create a transaction. How I do this is I just do Sentry SDK, start transaction. I have to give it a name, load messages. The name is important because that's how you find it in the performance overview page. And I'm going to show that to you later. I also have to give it an operation. I will also show that to you later, what the difference between name and operation is. Let's just call it UI load. Most important is that I finish my transaction, because if I don't finish my transaction, the SDK doesn't know when to send it, and it won't be sent. And I also want to have now two different spans, measuring the time of getting the messages and also measuring the time of sending the message, rendering the messages. So let's just call this get message span, get. And if you remember from before, I said that every transaction can have multiple spans. And how I do it is just I create a child of that. So that is now a child of my transaction. Get message span, I just call this db.load. So this would be how you could, for example, now measure your database queries manually, of course. In the future, we hope that we provide support for many, many database libraries that you don't have to do that manually. And in here in the callback, I, of course, need to finish that. And now I want to say transaction start child for the rendering. I just call this UI render. Render span. And I also need to finish that. Beautiful. And if I just hit play here, so let's compile this. Usually it's faster. Okay, now here we go. And I will just capture transaction. Here it is. Okay, I see in the log that something happened. And I now can go over to my performance overview page. And this is where I see all my transactions. Here I can change the environment. That's pretty similar to what you use to issues. Here down here, I see all those transactions. And this is here where the name is important. This is load messages. So when I click on this, I see all the transactions with the name load messages. Here I get a nice duration breakdown of what the duration of my transactions is. Here I don't have really enough data, but if you use it in production, it would look something like this, where you even see the different percentiles of where the range of the duration of your transactions is. It's pretty cool. You can also change it to different things and get different views on it. And down here, I see the individual transactions. And here I can filter, meaning, okay, now it shows me the slow transactions, because normally that would be the transactions I want to investigate. But I just want to have recent transactions here. So it's sorted by the incoming transactions. And here I see, okay, this transaction is just from a few minutes ago. This is the detailed view of a transaction. Here I actually see this is the transaction with the operation, ends up here, the name ends up here. And here I have the two spans as children that I just created manually with DB load and UI render. And I didn't give them a description, so it's just the span ID. The cool thing is with the operations is you kind of should treat them like tags or something, because in the view here, if you have plenty of spans, you can filter by them. And there are also some metrics and statistics that we provide that are based on those operations. On the transaction here as well, we see tags as you're used to in events. We even have breadcrumbs and all the other device contexts that we have on our events as well. Okay, that was how we manually create a transaction. But of course, doing that for everything kind of is not what we want you to do. So we want to take a look at how the auto-generated transactions look like. And we have a very simple view controller that just loads some texts and throws it onto the view. And if I click here, it just pops up. And maybe I do it again. You see clearly that here is some delay happening, and there might be a performance problem, and we should look into that. Okay, then let's go back to the performance overview page. And here now, maybe we can just switch to the view that I was talking before. So here you see the cold start, warm start, slow and frozen frames. And if I change this to last 14 days, you see that that changes accordingly. So that's the time span. And I also can change here the cold start distribution to warm start distribution. I can also take a look at that. This really gives you good insight in how long the application needs to launch. This here is actually way too long for an iOS application because I use the simulator a lot. So if this would be a real application, I would be really in trouble because 2 seconds is definitely too much for an iOS application. Okay, now let's go to this view controller. Again, go to recent transactions. And I have mine from just a few minutes ago. And I can take a look. And here I see that I have a frozen frame here on the right. I was talking about that before. This means that one frame took longer than 700 milliseconds to render. And this is also the hitch that we saw previously when I was clicking in the simulator. And I can see here that the view did load took around 800 milliseconds, which is very, very long. Those 500 milliseconds for the view appearing is fine because that's the animation that we have. So we should investigate this. Okay, I just have here my controls. Okay, here. Okay, let's investigate this. And I would be curious. I mean, here it's very obvious that that's the only thing going on here, that this is the thing that's slowing down my UI view controller. But I just want to make sure that this is exactly the code that's slowing my application down. And of course, I could now create another transactions as I did it before, but that's not nice. Ideally, I would see a span in this transaction here telling me where I spent most of my time. And luckily, we can do that. What we can do is, I think Bruno mentioned that before, we can go to the SDK and just call .span, which gives me the current ongoing transaction that the SDK is generating for you. And I can just call it to start another span. let's just call it UI.load. And I finish it afterwards here. And with that, I can attach a span to the auto-generated transaction. So this is really powerful. You can create another whole huge tree of spans that you just, if you're not satisfied with what we give you, and you get loads of more insight. Okay, again, I just capture 2 transactions. And now we need to hope that this is already here. Nope, sometimes it just takes a few seconds until that pops up. But in the meantime, for example, I can show here, you can also click on View All Events, where you get a better overview of all the transactions that are around here. You can sort them by timestamp. You can even filter by user ID or, I don't know, SDK version, any parameter, any tag that you find, you can filter that here and it will just show you those transactions. So let's hope that that's here right now. Yeah, the transactions are here. And here I have another UI load span. So I should have given it maybe a name so that I would be sure that this is mine, but I know this is mine because I just added it. So I'm pretty sure that this is slowing down my application. So let's just fix this by moving that to a background thread. So we just create a dispatch queue. For those who don't know what a dispatch queue is, it's just a fancy way of executing something on a background thread. Just make this real quick and hacky. This is how we throw it onto a background thread. And of course, all mobile developers know I need to make sure that this runs again on the main thread, because otherwise I would crash my application. Sorry. So that would make it faster, but I also know that I can optimize this like crazy by just reducing delay here to 100 milliseconds. That's the best optimization I can do. Just compile that again. And when I click here, I see immediately that this is way smoother. So I don't have that delay. I see that slight delay that I kick off on the background thread, loading something from the file system and just putting the text here. Okay, let's go back and go again to the transaction summary and hope that my transaction is here already. Seems like it's here. Yeah, and here I see, okay, my UI load still takes around 200 milliseconds, but the viewDid load now only takes not even a millisecond. And I got rid of the frozen frame. I still have a slow frame here, which is not that optimal, of course, but the frozen frame is gone. And I also, that the duration of the transaction went down from 1 second to around 500 milliseconds. So now we fixed it. And of course, we also want to, as developers, we also want to avoid regressions and to be notified if that gets slower. And something that we can do is we can just click here on create alert, and we can create an alert rule for this transaction, for this screen that is loading here. Here I again can select the percentiles that I want, so that I just don't be notified if 1 or 2 transactions take way too long, because I don't know, maybe there's some conditions happening which are not really relevant, but I just want to make sure, okay, if multiple of them are over this, what I specify down here, then I will be notified. I can also specify the time interval. So not only if this is happening for longer than 10 minutes, and maybe let's say, okay, if this takes longer than 800 milliseconds to load, it's critical, and I want to receive a warning if it's slower than 700 milliseconds. Down here, I can add an action. So I will just select me, that I receive an email. If you have integrations, you can also, I don't know, send a Slack notification, PagerDuty, whatever, depending on what integrations you have. Just give this a name, save it, And then I would receive an email if multiple transactions come in and they are slow. But now I'm going to delete it again because I don't want to receive some notifications here. And that's how we fixed a slow screen, which is kind of now using synthetic methods with real user monitoring. So you could also use that in development, of course, if you're not familiar with a profiler, which can be pretty complex and hard to understand. So you could also use Sentry during development to speed up your application. Okay, lastly now, we want to take a look at the app start. And we want to understand how long our application takes to load. So here I see the transactions which have metrics for app start, for cold and warm. Let's just click on this one here. And I just want to click on the recent ones and take a look at this one. Again, for an iOS application, this would be way too slow because our application is almost doing anything and it needs almost a second to launch. So this would be really bad, but on a real device, it takes around 70 milliseconds. So it would be fine. I have all these spans here that I was talking about before. And the cool thing now is here is where distributed traces comes into place. So as we add a span here for this HTTP request, like Bruno said before, we add an HTTP header, a Sentry specific HTTP header. This gets passed along to the backend, and as the backend is a Java backend, has also the Sentry SDK installed, it's just picking up that trace header and sends that information to Sentry. So we get those two transactions sent to Sentry, and Sentry then just does the magic and puts those two things together to a trace. So here I am in my iOS Swift view controller. I can click on view full trace and I see the transaction that's happening on the backend. I can just click on this, you can click on view transaction, and I see what's happening here on the backend. And I can immediately, I don't know, say, okay, this is not looking good. I can go over to the backend guys and tell them, hey, come on, fix this. I even see here that an error happened, which is also pretty cool. For every SDK, when an error is happening during a transaction, you get a link so you can directly navigate to the error from the transaction. Oops, that was not what I wanted to do. I wanted to click here. So here I see the exception happening in Java. And also this issue here has a link back to my initial view controller transaction. Okay, that was how distributed tracing works. And I think that's it. Oops.
Awesome stuff, Philip. Thank you so much.
Yep, we can open it up for Q&A then.
Great. It looks like some of them have been being answered by Bruno. I'm going to highlight a few of them that I just want to make sure everyone hears out loud. There's a couple related to tracking battery usage. I think they're different. The first one is there any way to track battery usage? And then the second one is, can I track something like how much battery is used in a particular session? So we'll address those together.
Yeah, so I think I try to address them as a comment this ones, but basically the SDK will report the battery status at the time of an event, but it's event based. So like if there's an error, I want to know like, was the phone about to die out of battery? Like what was going on? But it's not like a histogram like battery over time, you know. So this is not in the performance bits that Philip was showing. It's about, you know, traces. We loaded this view, how long it took 500 milliseconds. So if we measure how long, like how much battery in the beginning of this and at the end, it's likely not going to ever be much of a change, right? So for a feature like this, it's basically not something that that we're doing right now. We do plan to support features like this, but it's just something that will come in the future. So hopefully this answers. And there's one, Schaefer, if you don't mind, I would like to, there's a good question here about that we kind of answered the first part in the beginning about how if you have a hybrid SDK like Flutter and React Native, how do you do it, you know, in terms of, there are 3 layers, right? There's the Swift one and a Kotlin one, React Native one. So our current performance monitoring product will, for React Native, for example, will capture transactions on the JavaScript layer. So your spans will be related to your XHR and fetch and, you know, routes and things like that. So the auto performance that we have on iOS, for example, that is assuming that you have different view controllers. And that's not the case with React Native. There's one view controller, and then JavaScript kind of renders there's a JS, of course it's native, so it still binds to new things. But it basically doesn't play very well together. It will be kind of duplicated. And there's also an overhead to try to capture everything over the bridge. But it's basically, we want to have better integration between the hybrid layer and the inner layer. For example, how long did this bridge call take? I think that could be very valuable to anyone doing hybrid SDK, but it wouldn't be valuable for you to enable our iOS instrumentation on your React Native app the way it is built right now. It's designed for apps built native apps or hybrid apps. So hopefully this answers.
Cool. Yeah. Thanks.
Just one more clarification. Our hybrid SDKs include the native SDKs. So you don't need to install the 3 of them. They are already installed for you automatically.
Great. Yeah, thanks for bringing that back up. Just from the battery question, another question kind of popped up about tracking memory usages. Is that something that we support?
I would say not yet, right?
Yeah, so I mean, Philipp actually shipped a feature last quarter for out of memory on iOS. On Android, we can also capture out of memory in Java, since those any native, basically it will crash the app and we can capture that. But again, those are events, right? Like ran out of battery. This is really bad. This happened. But like a graph of battery over time, that's not something that Sentry has in the product yet.
Got it. This one was answered, but again, just wanted to address it so that the larger group could hear it. Is there any way to automatically track some networking metrics for OK HTTP? Example, time to first byte or time to last byte?
Yeah, so we capture bytes sent, bytes received. We don't capture time to first byte because this is multiple layers inside what OKHTTP is doing. It's just relying on some operating system libraries to resolve the DNS name, to TCP libraries to read and write bytes into the network. It is something that we can still do through bytecode manipulation, but it's not something we're doing right now. We're measuring like how long the HTTP request took and breaking up what happened within it, like how many bytes flown in the beginning or how much was establishing a TLS connection, things like that. It's not something we do right now.
Great. Does Sentry auto-generate transactions in React Native when navigating to a new component?
If you're using the React navigation version 4 and 5, we do. If you're using the React navigation router, what's the name? The Wix router, the one made by Wix, that we will add this quarter. And yeah, so these are the ones we support right now. And if you want one that we don't support, please go to github.com/getsentry/sentry-react-native and let us know.
Yeah, that's all what Bruno said is there are a ton of things that we could still do to improve the performance product, but it's really hard for us. I mean, just released it. It's really hard for us to prioritize them correctly. So if you have something that you really want, just go on GitHub, let us know, open up an issue. If there's an issue right there, just upvote. So we, it's easy for us to prioritize the features that you want better. Yeah.
Cool. Just a follow-up question from Brittany about React Navigation version 6.
To be really honest, I didn't even know there was a V6 already. We just added V5 just a few months ago. So yeah, I mean, please raise an issue and we can get some thumbs up and prioritize this. We're constantly adding new integrations.
Great. Question from earlier that we didn't get to was, we've just started using Sentry for our React Native app. How can I see or pinpoint which section results in ANRs?
That's a good question. Section is results in ANR. I'm not sure I really follow it though.
I was looking at it. I also didn't fully understand the question. Yeah.
Cool. If you're Ronak, if you're still out there and you can like potentially try to rephrase the question, we'll come back to it and answer it before we wrap things up, or we'll just follow up with you afterwards when we can get an answer. someone is asking, what will be the best sample rate when there are, say 3,000 users on a production app?
Can I try this one? I would start.
Go ahead. Yeah.
I would start with like in dev when I'm trying locally, 100%. So everything you do, you see it. And before going live, I would put it 1% just to see what happens, and I would ramp it up from there. That's what I would do. Unless you had 3 million users, then I wouldn't even use 1%. I would probably use less, but I think not a lot of, it's not very common to have that many concurrent users. 3,000 is probably okay.
Yeah, I would even maybe go with a higher percentage because you just have 3,000 users. So most likely they're not going to blow up your code immediately. But yeah, it depends on what you want. And also depends kind of what your user distribution is. If all of them, I don't know, for example, iOS users and they have similar phones, so then most likely you won't have, I don't know, a huge distribution of different durations of your transactions. If you have like loads of different Android users and they have different phones, so then maybe I would not drop that many transactions. I want to know like more of them, because it could be that some of them are experiencing issues. If all of them have similar phones, you can go with a lower number. I think it really depends, but yeah. Also, what Bruno said makes sense. Yeah.
Yeah, that's true. There's one additional concern, which is your quota. So if you have too many users and you go with too high of a sample rate, you might just burn through your quota too quickly. So that's why just, even if it's not optimal yet, maybe for the size of your company, you would need more transactions, but usually you can fine tune this easily. It's just easier to start with a small number, take a look, see your quota, and then you just ramp it up from there. But yeah, makes sense that we wouldn't stay on the lowest one.
Can we also talk about the feature that might fix this issue, Bruno? Or I think it's.
I would say we're working on something that
yes.
I'm not sure how much.
Okay. Yeah. Okay. We're working on something to fix the problem for you. Let's put it like that.
Easier.
That's cool.
Yeah.
Can we also track scrolling lags from Alexi?
Scroll lags. Do you mean like, where is it, like in every platform? I mean, those slow and frozen frames kind of already give you a hint, I think. So if you have plenty of them while something is scrolling, I mean, the current problem is that the transaction kind of ends after a screen is loaded. So we don't yet have transactions while you're scrolling. But what you could do is, especially on iOS, you could just create your own transaction and those measurements should still end up there. On Android, I'm not 100% sure if we also put the measurements there yet, but I think we have plans on doing that. So then if you have loads of slow frames, that would also tell you that you have hitches while you're scrolling. So that's what you could do right now. But yeah, if this is a concern for many users, we can maybe think of how we can add that you get that out of the box. But it's a good input. Thanks.
Yeah, it's also it's on these questions useful to specify which platform, which SDK you're using, because we have there sometimes at different stages. On React Native, it's something we're already looking at into hooking into motion kind of gesture libraries to extract more performance data.
Great. We've got 3 more, and then we'll wrap things up. Is it possible to see concurrency rate in Sentry? No,
I'm not sure what you mean by concurrency rate.
Yeah, I also don't get.
All right, Byung, if you want to clarify in your question or just elaborate more on what you mean by concurrency rate, we'll come back to it. Would the performance monitoring setup in docs be all that's required to capture vitals in React Native?
Yes.
Yes.
Yes, there is one note. The JS stalls are already there, but like some of these measurements on React Native are still on beta. But on iOS and Android, so some of it relies on iOS and Android, so we had to ship that first before we could ship React Native. But if you wanted, there was a release yesterday. If you want to try that out, that's what we plan to GA next week.
Cool. Back to Byung, who has clarified, like how many people are using the app in a certain span of time or in a certain screen of an app? think that's what he means.
Yeah, that I think goes more into the direction of user tracking and like in getting some marketing statistics. And that's a road that we currently didn't go down yet, right? As far as I get it. So we don't do that currently yet, right?
Yeah, I think Sentry is more like focused on, it's a tool for developers to help you understand when things are going wrong, or if your app is slow, users have a bad experience. So and this kind of metrics is not something we're looking at right now.
Got it.
We do have sessions which are enabled by default in all our mobile SDKs. So you have an idea of how many different users are using your app and how many of them have bad experience, say errors in the sessions or crashes, versus people who had a session without any issues. That you know, looking at quality, right? Cool.
Great. Final question. When catching, excuse me, when catching ANR, does Sentry pick up everything from traces.txt generated by Android, or is it a subset of it?
Where is the question?
So looking for it. I'm not sure what you refer by traces.txt. The way we do tracing, we don't rely on like reading any text file. I'm not sure what this one would come from. So the support we have for ANR, it's, you know, ANR is an event on the operating system. On Android, it's basically your app's going to be killed because the UI thread's blocked by 5 seconds. And we will raise an issue to Sentry and you'll be notified and you can see how often this happens, etc. And which threads or the stack trace at that point in time and different threads. But that's the extent of it. Like in terms of performance, we will capture the duration of traces and the spans within those transactions. And this should help you understand how long things are taking to load. But separately from the ANR, like error reporting side of things, if that makes sense.
Great.
And that's for Android, by the way.
Thank you both for your time today. Looks like we're done with questions. Thanks everyone for joining us today. This was awesome. We'll do this again late next month, early in October. I'm not sure about the topic yet, but stay tuned. Don't forget 2-question survey just as you leave or as I end this meeting. Just kind of helps us figure out if what we discussed was helpful and what topics you guys want to hear about in the future. So please fill that out. It takes less than 30 seconds, hopefully.
Nice. And there's if I have a chance of saying one more thing before we go.
Sure.
Sentry has a Discord server that you can reach out and we talk about building Sentry. I just wrote it on the chat. The link is discord.gg/Sentry. And you know, if you have requests for features like integrations and things like that, we're happy to discuss it over there.
And if you don't manage to save this URL somewhere right now, just go to our GitHub repositories, and usually each of them have also a link to Discord, because I think they are easier to find.
Great.
Cool.
Yeah, join that community. Real-time conversation happening over there. A chance to share feedback as well. So good call out, Bruno. Great. Well, until next time, everyone, thanks for joining. We'll get the recording out to you as soon as we process it, and have a nice rest of your week. See you next time.
Thanks for your time. Bye.
Thanks, Schaefer. Bye. Bye, everyone.